network layer. So network layer provides us variety of services. For example, the first very important service that network layer provides us is basically the forwarding service, or it gives us IP protocol, internet protocol, right? So this IP protocol is basically a forwarding protocol. So forwarding protocol. So router forwards a packet based on the IP address given by this internet protocol address. And we'll also be discussing, while discussing this forwarding protocol, its datagram format and how the packets are handled. What are the different handling conventions? Then the network layer provides us also a signaling protocol known as ICMP, Internet Control Message Protocol. By the way, this Internet Control Message Protocol is called signaling protocol. It's a signaling protocol that is used to report errors. And then we have different types of routing protocols at the network layer to forward data from one machine to the other machine. Before we start discussing internet protocol, let me quickly have a discussion about the packet switched networks. Since the internet is a packet switched network, so it's important that we briefly discuss this packet switched networks first. So let's talk about packet switched network. So the internet is based on packet switched networks. Internet is a packet switched network. So we have briefly talked about the packet switch networks in our previous lectures. So in packet switch network, we know this, that data is packed in packet switch network. The data is packed into packets or datagram. So the data is encapsulated, or you may call it parceled, into packets or datagram. And each packet importantly carries a destination address. And each packet carries a destination address. And most importantly, each packet is routed independently. Each packet is routed independently. This means a packet one can take a different path to reach the destination, and second packet can take altogether a new path to reach the destination. And there is a possibility that packets can arrive out of order. So this is so, and we know this. We have discussed this also at this concept at the transport layer, that packets can arrive out of order. Okay, and this is also possible that packets may not arrive at all. Packets may not arrive at all means the packet has lost, right? So you can compare such a network, means a packet switch network, uh, with your postal system. So we can have an analogy of postal system to understand it. So for example, what happens in a postal system? What you do with the content that you want to send? Yes, so the content you want to send must be put into an envelope. So the content you want sent must be put into an envelope. Right? And what else? Yes, an envelope must have an address, right? And the envelope must be addressed. So in the case of our packet switch network, uh, the envelope is basically uh, the packet header. So in packet switch networks, the envelope is the packet header. And remember, we have discussed earlier that are protocols are set of rules and regulations are rules. By rules, I mean to say it has a syntax and grammar, certain meanings. And in this case, the protocol uh, governs, or these rules are governing communication between nodes. Right. And uh, obviously, the format of the header, the format of the header is part of a protocol. So the format of a packet header is part of a protocol. Right. So for the packet forwarding on the internet, the protocol is called or is known as Internet Protocol. Right? So here, the protocol that I'm referring to is, in fact, Internet Protocol or IP, and we are interested in looking at the format of the packet header of the protocol, means the format of the IP packet header. So, so for packet forwarding, on the internet, The protocol is the Internet Protocol. Or IP. Right. So this means that packet switch network, the internet is basically based on packet switch networks, where the data is packed into packets and then transmitted on the network. And the forwarding protocol is known as internet protocol, and we need to look at the internet protocol packet headers, the envelope, uh, so to examine what are the different fields and what's the purpose of the different fields of an IP datagram header. But before we talk about the IP datagram header, let's talk about the other alternatives, because where we have this packet switch networks, there are many alternative network architectures um, uh, available, right? So we have variety of alternative network architectures. So let's also talk about, in comparison to this, that what are the alternative network architectures. Okay, and uh, by the way, these include ATM and frame relay. ATM and frame relay. This ATM and frame relay uh, are basically circuit switch networks. So we call it virtual circuit network. So basically, there are two types of networks. So we have packet switch networks, and then we have virtual circuit networks, right? So the virtual circuit networks also use connections at the network layer. These network layer connections are obviously called virtual circuits, and these networks are called virtual circuit networks, right? And every virtual circuit network or a virtual network, virtual circuit network consists of, number one, a path, right? A path between the uh, source and destination host, and this obviously includes a series of links and routers. Number two, it has a virtual circuit number or virtual circuit numbers, one number for each link along the path. We'll see. We'll try to understand it with the help of an example in a minute. And number three, obviously, there are entries in the forwarding table of a router. The forwarding table of uh, each router. Right, try to understand it with the help of an example. And we'll also try to differentiate the packet switch network and virtual circuit network with the help of this example. So, for example, we have our machine A, and machine A is connected to router R1. Router R1 is connected to router R2. And router R2 is connected with machine B. And then there are other routers as well. So here we have router R3, and here we have router R4. So R1 is connected to R3, R3 is connected to R4, and R4 is connected to R2. Right, and let's suppose that the path that has been chosen to forward data from A to B is this. So the path is forward packet. The path is A to R1, and from R1 to R2, and from R2 to B. And let's assume that following VCs or virtual circuit numbers are assigned. So the virtual circuit numbers are, say, 1, 2, 2, 2, let's assume 3, 2. Right. So this means when a packet is forwarded from A to R1, or when a packet leaves A for R1, it has virtual circuit number 1, 2. When the packet leaves R1, the value of the virtual circuit number is 2, 2. And when the packet leaves R2 for B, the value of the virtual circuit is 3, 2. So what happens basically, in a virtual circuit is that every router needs to maintain connection state information. So all these routers needs to maintain connection state information. Okay, and so this communication happens basically in 3 steps. So step number 1 is, or 3 phases. Phase number 1 is we establish a virtual circuit, right? So virtual circuit is set up, right? So this phase is basically a setup phase, right? And then we transfer data from A to B. So this phase is called data transfer phase. And the phase number 3 is called virtual circuit teardown. After sending the packets, we terminate this connection. So what we are doing here is that, first of all, using this virtual circuit networks, we first of all establish a connection. We set up virtual circuit. For example, we have established that this is the path that all the packets will use to travel from machine A to machine B, right? And for that, the router maintains a forwarding table. Right? So in order to facilitate this, the router maintains a forwarding table. For example, we can look at the forwarding table of, say, R1 in this example. This is the forwarding table in R1. Right. So it, first of all, it has the incoming interface. Then it has incoming virtual circuit number. Then we have outgoing interface. And then we have outgoing interface, VC number, outgoing virtual circuit number. For example, in this case, the interface is 1, and what is the incoming virtual circuit number? Yes, you're right, 1, 2. And what was the outgoing interface? Let me label these for your understanding. So this is a 1, this is interface 2, and this is interface 3, right? So the outgoing interface is 2, and the outgoing virtual circuit number is, 22, right? So in this way, we have many different entries against each interface to forward packets based on virtual circuit numbers. So this is how data is forwarded in virtual circuits, where we have a specific path and all the packets will follow this path, right? So for example, I have to send 3 packets, P1, P2, and P3. All packets will follow this path. So packet 1 is packet 2, and packet 3 will also take this path. But let me take the same example and talk about the packet switch network. So if this would have been, if this is a packet switch network, so what will happen? This is a possibility that packet 1, so this is P1, P1 take this path, it takes this path, and packet 2, it takes this path to reach. So this is the path taken by packet 2, right? And similarly, if there is another path between, say, R3 and R2, so I can say, so let's assume that now the packet 3 is taking this path to reach. So each packet can take independent path to reach the destination. But in virtual circuit networks, we have a specific path that the packets have to follow in order to reach the destination. And the origin of these virtual circuit networks is based on the traditional telephony